Okay, today we're going to look at lesson 3.6, solving systems of linear equations in three variables. Our first example, of course, the directions are to solve the system by the elimination method, sometimes called the addition method or linear combination method, but we'll refer to it as the elimination method here. And the first problem we have is the 1, 2, 3 type. The reason we call that 1, 2, 3 type is because our first equation has only one of the three variables, our second one has two of the three variables, and the third equation is the only one with all three variables x, y, and z. I should say that when we solve a system of three equations and three variables, that we're looking for an ordered triple for the answer. So there'll be an x, y, and a z as well in our answer. So we're looking for an ordered triple. Okay, so step one is going to be to solve this the one variable equation. So we take negative 2x equals negative 6, and we solve this. So we're going to divide both sides by negative 2, and we find out that the x-coordinate of ordered triple is 3. So we're looking for two more after that, x, y, and z. We take that answer and we plug it into the two variable equation. So this would become negative 2 times 3 minus 3y equals negative 3. And we're going to solve that. Negative 6 minus 3y equals negative 3. Add 6. Negative 3y equals 3. Divide by negative 3. And the y-coordinate is equal to negative 1. So we know that's negative 1. Now that we have two of our three, then we take both of those to the three variable equation. We plug in x and we plug in y. So we'll have 3 plus negative 1 plus z equals 4. So plugging x in, or 3 in for x and negative 1 in for y. Collect like terms here. We get 2 plus z equals 4. And subtract 2 from both sides, z equals 2. So our ordered triple is 3, negative 1, 2. Okay? You try one. All right. Take the first equation and solve it. Take the 1, solve the 1. And we get x is equal to 1. So we'll put our ordered triple up here. X is equal to 1. Plug that answer into the two variable equation. So this becomes 2 times 1 minus y equals 4. 2 minus y equals 4. Subtract 2 from both sides. Negative y equals 2. Careful now, this is not solved for y yet because we have the negative sign, or it's a negative 1 in front of it. Divide both sides by negative 1 and y equals negative 2. Negative 2 is our y-coordinate of our ordered triple. Now that you have two answers, two of the coordinates, you can plug those two into the three variable equation and get your last variable. Okay, so this equation becomes 3 times 1 plus 2 times negative 2 plus z equals 2. Multiplying, 3 plus negative 4 plus z equals 2. Negative 1 plus z equals 2. Add 1 to both sides. Z equals 3. So 1, negative 2, 3 is the solution to the system. Okay, moving on to the next type problem. Solved by the elimination method, and this is the type 2, 2, 3. That describes the system and the equations. This first one has two variables of our three, the second one has two variables of our three, and the third one has all three. Okay, so what we want to do for starters is to take the two variable equations and create a 1. So we're going to change the 2, 2, 3 into a 1, 2, 3 basically. So take your two variable equations, 2x minus 3y equals 2 and 5x minus 5y equals 15, and eliminate something. Eliminate one of the two variables. Now when we eliminate, we create opposites in front of one of the variables. So as we look at the x's, 2 doesn't go into 5. In the y's, 3 doesn't go into 5 either. So there's not going to be a real easy one. They're not already opposites either. So what we're going to have to do is multiply both equations by some number that we think up that's right for this system of equations. So if we deal with the x's, we would be looking at the least common multiple for 2 and 5, which would be 10. If we deal with the y's or eliminate the y's, we're having to look at 15 as the least common multiple. Since 10 is smaller than 15, I recommend eliminating the x's. So we'll choose to eliminate x on this first step. To eliminate x, we have to create a 10 and a negative 10. And it really doesn't matter which one's the negative, but we just have to have one of them be negative. So I'll make this top one be negative. I'm going to multiply by negative 5 because that's what will make this a negative 10. But everything's going to have to be multiplied by negative 5, not just the x. And I'm going to multiply this one by positive 2. That'll give me a positive 10. So multiplying, we get negative 10x, positive 15y equals negative 10, and positive 10x minus 10y equals 30. Okay. When we add, the x's add out. 10 and negative 10 is 0. 0x we don't have to write, or we say it eliminates. And 15y and negative 10y give us 5y. And over here we add and we get 20. Solve for y, divide both sides by 5. And now we know what the y coordinate is. The y coordinate is 4. Okay. So up here, where our answer is going to be, we know that the y coordinate is 4. All right, we take 4 to a two-variable equation in the original problem. Well, I have my choice. Doesn't matter which one I pick. I'll just pick the top one. So the top equation is 2x minus 3, and instead of writing y, I put in 4 for y equals 2. Solving that. 2x minus 12 equals 2. Add 12 to both sides. And 2x is equal to 14. And divide by 2, and x is equal to 7. 7 is our x coordinate of our ordered triple. Our ordered triple is in there as x, y, and then z. Okay. All right, now that we have these two, then we take the three-variable equation and we'll plug x and y in it. So we'll put 7 in for x, so this becomes 2 times 7 plus 3, and we put 4 in for y, plus z equals 9, multiplying 14 plus 12 plus z equals 9, adding like terms, 26 plus z equals 9. Solve for z, subtract 26 from both sides, and z equals negative 17. So the solution to the system is 7, 4, negative 17. All right? All right, so let's review. What did we do? We took, with a 2, 2, 3, we take the two 2's and create a 1 by eliminating something. We solve the 1 and plug it into either one of the 2's, it doesn't matter, and we get a second coordinate of our answer. We take both of those to the three-variable equation, and we find the third one. All right, you give it a try. Okay, well, let's go ahead and work this one. Take the two 2's, or write them down, 5x minus 4y equals negative 3, and 2x plus 2y equals 6. And eliminate something. What will we eliminate here? Let's take a look. Well, 2 doesn't go into 5, but 2 does go into 4. So that's going to be the easiest thing for us to do, is to eliminate the y's. It'll take less multiplying. We can do it by multiplying the bottom equation by what? We want to get a positive 4 and a negative 4. We already have a negative 4. To create a positive 4 in this one, I'll multiply everything times 2. So the bottom equation times 2. 2 times 2x is 4x. 2 times positive 2y is positive 4y. Little mistake there. Positive 4y. And 2 times 6 is 12. Copying down the top equation and writing it underneath, 5x minus 4y equals negative 3. Okay, and then we add. We get 9x, the y's add out, equal 9. We divide by 9, and we get x is equal to 1. So 1 comma. And now take this, plug it into either one of these. I'm going to plug it into the second one. It looks easy. So it's 2. Instead of x, I put 1 in for x in the second equation, plus 2y is equal to 6. 2 plus 2y equals 6. We subtract 2. 2y equals 4. We divide by 2, and y is equal to 2. Our y coordinate of our solution is 2. Take these two to the 3 variable equation and plug them in. 3 times x, but we put 1 in for x, minus 3 times y, but we put 2 in for y, plus z equals negative 3. Multiplying, 3 minus 6 plus z equals negative 3. Collecting like terms, negative 3 plus z equals negative 3. Add 3 to both sides. Z equals 0. It's perfectly fine for 0 to be one of the coordinates. And that's the solution to our system. 1, 2, and 0. All right. Okay, moving on to our next type of problem. And this is, although I didn't label it, this is the 3, 3, 3. Okay? Well, here's what we do with the 3, 3, 3. We change it to a 2, 2, 3, and then we change that to a 1, 2, 3, and then we solve. So, step 1 is to select, not like that, we'll say make 2 different groups of 2 equations. Now, for this one, I like to number the equations, so we'll call that number 1, and this number 2, and this number 3. Okay, make 2 different groups of 2 equations. So, as I look at this system, I'm liking with the idea. Okay, we make these 2 groups with the idea of eliminating the same variable in both groups. So as I look at this, I like pairing equation 1 with equation 2, and pairing equation 1 with equation 3, and eliminating x, because I can see if I add this x to this x, the x will go out, and then if I take this one and times it by negative 2, this one will go out. Now you can do this in a, you can make different groups and it'll work, but for me this is the way I'm going to do it. So I'm going to take equation 1 and I'm going to pair it with equation 2, and I'm declaring that I am going to eliminate x in both pairs. Now that's important. You cannot change what you eliminate. You have to eliminate the same variable in both pairs. So copying down equation 1, I get x plus y plus z equals 6. Equation 2, 2x minus y plus 3z equals 9. The idea is to eliminate x. So I need a negative 2 here. So to get that, I take equation 1 and times it by negative 2. Multiplying through and writing it underneath here. Negative 2x minus 2y minus 2z equals negative 12. And we add. Of course, the x's eliminate. That's what we planned. Negative 1y and negative 2y is negative 3y. 3z and negative 2z is plus 1z. 9 and negative 12 is negative 3. Okay? So we started out with two 3-variable equations. Now we have a 2-variable equations. Again, we're going to change the 333 to a 223. Now here's where the other 2 is coming from. So I'm going to pair equation 1 with equation 3 now. A different grouping of 2. 1 and 2 is different from 1 and 3. Although they have one in common, it's a different group of 2. Okay, so equation 1, x plus y plus z equals 6, and negative x plus 2y plus 2z equals 9. Now, if we want x to eliminate, these are ready to eliminate right now. So I can go ahead and add. I don't have to multiply either one by anything because I'm eliminating x and it will happen right now. So we add these two without doing anything else, and the x's add out. And y and 2y is 3y, and z and 2z is plus 3z. 6 and 9 make 15. So if you look at what we have right now, we have two different 2-variable equations in the same 2 variables, y and z, and then we have our choice of 3-variable equations. So we are at the 223 right now. What did we do with the 223 the last time? We took the two 2's and eliminated something and came up with a 1. So what I'm going to do is I'm going to write these two 2-variable equations together. And so I think I'll just write this one underneath it over here. So I'll put 3y plus 3z equals 15. And what do we want to eliminate? We have to eliminate another variable, and clearly we want to eliminate the y's because we don't have to do anything for that to happen. They're already opposites. Now that doesn't always happen. A lot of times we're having to multiply both equations by something to get opposites, but this problem, they're already opposites. So we don't have to do anything but add now. And 3y and negative 3y is 0, or it adds out. Z plus 3z is 4z. Negative 3 and 15 make 12. And right now we are at a 1, 2, 3 problem, and we'll solve it just like we did the very first problem. Once you get to the 1, 2, 3 stage, you solve the 1. And then z is equal to 3. So our ordered triple, we know that's 3. I don't want that to be confused with this, with our I want to get that confused with the name up here, so I'm going to erase that for right now. And now we'll take this and we'll plug it into either one of these. It doesn't matter. You know, there's some room over here, so let's just plug it into this one. So it's going to be 3y plus 3 times 3. That's equal to 15. Okay. 3y plus 9 equals 15. Subtract 9. y equals 6. Divide by 3. Y is equal to 2. All right, take these two answers and plug it into a 3-variable equation. Now, on the very first problem, we didn't have our choice. I don't think we had our choice on the second problem either, but right now there's 3 of them that we could use. Use any one of these 3, and of course, one is begging to be used because it's so simple. So we'll plug z and y into the first equation. So the first equation becomes x plus, not y, but 2. We plug 2 in for y, plus, not z, but 3, and that's equal to 6. So we have x plus 5 equals 6. We subtract 5. We get x equals 1. That was as easy as 1, 2, 3. I know that's goofy. Okay. So there's the solution to the system where you have three variable equations. Okay? Let me go over those steps again. We started out, we numbered them 1, 2, 3, and then we made two different groups of two equations with the idea of eliminating the same variable in both groups. So it looked good to me to eliminate x, and I grouped 1 with 2. Here we did right here, and we eliminated x and got this. And we grouped 1 with 3, and we eliminated x and got this equation. Then we took the two variable equations that we just created, brought those together, and eliminated something else. Well, we eliminated y because it was so easy, and we got our one variable equation. We solve the 1, plug it into one of the 2's, and take those two answer and plug it into a 3, and that's our solution. Okay? You give this one a try. Okay, well, we have to look at the system and decide what might be the easiest variable to eliminate. You see the negative z and the positive z right here? Put these two together and z eliminates. And then I might take the top one and this one, or maybe the middle one and this one. It wouldn't really matter. So I'm going to declare that I'm going to eliminate z on the first step. Okay? And we'll number these 1, 2, and 3. And I have to do two different groups of 2. Well, first one's going to be 1 and 2, because the z will add out without doing anything. And then, you know, I like how small these numbers are. I might put 2 and 3. You could do 1 and 3 or 2 and 3. It doesn't matter. I'm going to put 2 and 3 here, just to be a little different. 2 and 3. Okay, so copying 1 over, we have x plus 3y minus z equals negative 11. And 2 is 2x plus y plus z having a little trouble here. Okay, computer finally caught up with me. Plus z equals 1. This equation is ready to add if what we want to do is eliminate z, and that's what we said we would do. So 1x and 2x is 3x, 3y and 1y is 4y, and that's equal to negative 10. Okay, copying down 2, we get 2x plus y plus z equals 1, and equation 3, 5x minus 2y plus 3z equals 21. Remember, we're eliminating z. So what we'll want to do is create a negative 3 in front of this one so that we add it to the positive 3 and it goes out or eliminates. So we're going to take this equation, the entire equation, and multiply by negative 3. Negative 3 times 2x, negative 6x. Negative 3 times positive y, negative 3y. Negative 3 times z, negative 3z. Negative 3 times 1 is negative 3. It's ready to add. And 5x and negative 6x is negative x. Negative 2 and negative 3y is negative 5y. The z's add out. And 3 off of 21 is going to be 18. Okay. Well, bring these two equations together and eliminate something. Well, let's see. I think I'm going to take this equation over here and write it under this one. So this one's going to come over, and I'm going to write it underneath this one so I don't have to rewrite this one. 3x plus 4y equals negative 10. And I'm going to eliminate the x's here, so I'll say that eliminate x out of these two. To do that, I'm going to take this equation, multiply it by 3. 3 times negative x is negative 3x. 3 times negative 5y, negative 15y. And 3 times 18, 54. And that's a 10 right there. And make sure it doesn't look like a 16. It's 10. I'm probably making it worse here. All right. We add, and the x's will eliminate like we planned, and we get negative 11y equals 44. We're down to the 1, 2, 3. Solve the 1. Divide by 11 by negative 11. And y is equal to negative 4. Negative 4 is our y coordinate. Take that and plug it into a 2. Let's do it into this one right here because there's a lot of room underneath here. So we're going to take this equation, 3x plus 4, and instead of putting y, we put negative 4 in, equals negative 10. Multiplying 3x minus 16 equals negative 10. Add 16 to both sides. And 3x is equal to 6. Divide by 3. X is equal to 2. And run get us a equation. Let's take this one down here and plug both of these variables into it. That middle one looks easy. 2, you can pick any one of them though. Putting 2 in for x plus negative 4 in for y plus z equals 1. 4 plus negative 4 plus z equals 1. 4 and the negative 4 cancel. We get z equals 1. And I forgot to put the 2 up here. We already got x is 2. The solution to this system is 2, negative 4, 1. Okay? Well, that concludes this lesson, and I'll go ahead and make the assignment to the class. Hope you enjoyed the video.